Section 2.3, Permutations when all objects are distinguishable. So permutation definition, arranging all or part of a set of distinguishable objects where order is important. Let's take a look at an example. What are the possible permutations or arrangements of the letters A, B, C? So just writing down the possibilities, we can have A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. So the order does matter. We can see just by listing those that there are 1, 2, 3, 4, 5, 6 possible permutations to arrange A, B, C. Furthermore, we can kind of consider that as I have 3 letters to arrange using our fundamental counting principle. There are 3 letters that we can choose to place in the first position, A, B, or C. Once that letter has been placed, there are now 2 remaining letters we can choose from to place in the second position. And similarly, there is only 1 left for that last position. And we multiply all of those together. This can also be written as 3 factorial, as we've seen in section 2.2. And again, when we multiply that, that gives us 6 possible permutations to arrange those letters. Let's take a look at example 1. How many ways are there to arrange 3 people of a group of 5 in a line? So consider that we are not arranging all 5 people in a line. We are taking 3 of those people and placing them in a line. So again, there are 5 ways to pick one person to put in position 1 in that line. Once somebody has been placed in that position, there are now only 4 people to choose from to place in position 2. And again, same reasoning, there are now 3 people left to choose from to put one person in that last position. And our fundamental counting principle tells us that we can find the number of total possibilities by multiplying all of those options together, and that gives us 60. So now we're moving into the permutation formula. There's another way to kind of consider this example. So permutation, NPR, N is the number of objects we can choose from, and R is going to be the number that we choose. So in the example above, this would be the N would be the 5 people, and the R, okay, N is 5, and the R would be the 3 people that we are choosing to arrange. So we're arranging a subset of items. We're not arranging all items. Only some of the items are used in the arrangement. So again, we are determining the number of permutation of n different elements taken R at a time. So if we kind of use this formula for this particular example, we have 5 items to choose from, and we are choosing 3 of those options. So again, if I had n is my 5, and R is 3, so we have 5 factorial over 5 minus 3 factorial. 5 minus 3, again, becomes 2 factorial. And let's just continue here. Again, we saw back in section 2.2, 5 factorial is 5 times 4 times 3 times 2 times 1, all over 2 factorial, 2 times 1. And we end up with the 2 canceling out. 2 divided by 2 is 1. 1 cancels out. And we are left with 5 times 4 times 3, which if we compare back to the fundamental counting principle, then we ended up with the same. So the formula may look a little different, And we will be using this formula quite a bit. One other thing that I want to point out here is this NPR and 5P3 particular can also be done on your calculator. There is a button on your calculator that shows up as NPR. So if you can now take out your calculator and plug that in, then you will end up with 60.